Computer battery fires have been in the news in 2016, so I thought now would be a good time to look at some of the basic physical principles and some of the history of computer battery fires. People are very interested in having batteries that last a long time. That means having batteries with high specific energies, that is, energy per unit weight. This chart shows the specific energy of several different types of material. You can see that lithium batteries, which are very high performance, high energy batteries, have an energy density about 40% that of TNT. Lithium ion batteries are widely used in consumer electronics and in other applications. Their energy density is about 15% that of TNT. So we see the fundamental problem is basic physics. If we want batteries that are compact and deliver a great amount of energy, we have to have high energy density. And at some point, those high energy densities reach potentially serious levels. So given that, let's look at the history of computer battery fires. And I don't pretend that this is an exhaustive history. I just brought up several examples that have come to my attention over the years. In 2006, Apple conducted a voluntary recall of lithium-ion batteries used in some iBooks and PowerBooks. The Consumer Product Safety Commission recall notice described that these batteries can overheat. They said that Apple had received 9 reports of overheating, including 2 minor burns from overheated computers and other reports of minor property damage. No serious injuries in these cases. In 2013, we had a battery fire inside a Boeing 787. The battery was in an airplane, on the ground, luckily empty of passengers. But this photograph, which is from the National Transportation Safety Board, shows the very serious damage that was caused to the battery by this fire. I call this a computer battery fire because these batteries were used to power the computers that run the airplane. The 787 had a great deal of computation and automation for not only advanced features, but the basic flight controls of the airplane. That meant that the pilots in an emergency needed a good amount of electrical power simply to be able to control the airplane. That required the installation of a high-performance battery. And unfortunately, in this case, the battery had a serious fire. So now we get to the news of 2016, in which we had several battery fires from Galaxy Note 7 devices. The Consumer Product Safety Commission put out a statement in 2016 that started off by noting that lithium-ion batteries pack a lot of power into a small package. They went on to urge Galaxy Note 7 owners to power them down, stop charging, or using the device. This warning was based on several recent reports in certain Note 7 devices that have resulted in fires. So we see that these recent reports aren't the first case in which we've had problems with computer batteries. And we've seen that the basic physics tells us that the energy densities of these batteries is pretty darn high. To summarize, computer battery fires have happened several times in the past for several different types of devices. And given the basic physics of batteries, and given their high energy densities, I think it's reasonable to assume that battery fires in computers are likely to happen again.